Good morning, YouTube. How's everybody doing out there? So I haven't live streamed in a couple of days, I think. This week's crazy. Had a lot of other tutoring, and there's a lot going on in the tutoring world and the standardized test world. So I'm Greg from GregsTutoringNYC at gmail.com. My email is at the bottom. I'm currently using the 2017-2018 student handbook. It's no longer online from the DOE, so if you want a copy, please email me so you can follow along. That said, we did a lot of the material already. We did all of Form A. I'm deciding what we should cover specifically in Form B. I'm not sure whether I have the time anymore to cover the whole thing by the time the test comes, because at this point the test is in 3 weeks. I'm covering grade 9 material, so please, guys, if you want to put comments on the stream or you want to have special requests or something, email me or put them on the side there so we can start figuring out some stuff. Let me see if we're live. We seem to be going all right. So I'm half thinking of doing a whole bunch more of grade 9 problems. And by the way, if you're in grade 8, these are all applicable to you. Some are harder than grade 8 problems, but some will be borderline because there's some problems that they'll always ask in both sections. And remember that probably about 75% of the grade 9 test in the ELA and the math section is grade 8, so-called grade 8 questions. So don't be kind of led astray with this. A lot of you guys want to focus on what are the grade 9 topics. In the meantime, they're all the grade 8 topics as well. So the grade 9 topics is a superset of the grade 8 SHSAT. All right, so don't remember to keep throwing that away. A lot of kids get so focused on only grade 9 specific stuff that they put themselves in a disadvantage by not considering or incorporating or thinking about or practicing any of the grade 8 stuff. It's okay to use the SAT for practice and things like that, but there's nothing like practicing for the test you're supposed to be using too at the same time. All right, so let's jump into question number 1. It should be on your screen okay. So there's no illustration here, so we're just going to jump in. To determine the price of servicing a car, a mechanic charges a fixed fee plus an hourly rate for each hour he works. If his price for 4 hours of service is $270 and his price for 7 hours of work is $420, what is the fixed fee that the mechanic charges? All right, so we can set up some symbols. And by the way, symbols don't always have to be, we can call the fixed fee FF. Okay, there's nothing inherently wrong with doing something like that. Okay, this is not in focus. Give me 1 second. Okay, there we go. And we have something like HR could be hourly rate, right? So let's just take each one at a time. So mechanic charges a fixed fee. And an hourly rate. And we're also given totals as well. So if his price for 4 hours of service is $220, so how do we map that into a math expression, a math sentence, a number sentence, right? If his price for 4 hours of service is $220, so his total is his fixed fee plus his hourly rate. And this would be times the number of hours, right? So if his fixed fee was, say, $50 and his hourly rate was $100 an hour, and you worked 2 hours, right? Those would cancel out. You get 200, so you would get 250 here. All right? That would be what the mechanic would charge you. So we need to come up with the 2 number sentences that map into that for what they're talking about here. So 270 would be the total. We know that. There's the fixed fee, right, plus 4 hours of service. So that would be times their rate. We can call it anything. Let's just simplify this and say this was R. So it's 4 hours times the rate. So there's 2 numbers here we don't know what they are. We don't know what the fixed fee is, and we don't know what the rate per hour is. But we do know the number of hours, and we do know what the total ended up being. So this by itself we can't do much with it. You know, we can wiggle around and say we know the fixed fee can't be greater than 270, because it could turn out that he works 0 hours, and we can make this some fantasy line like 1,000,000 hours, but that's impractical. And say the fixed fee is like a penny. Okay, so we know the answer has to be between those two, just given this. That doesn't help us. All right, but if we add the second one on, that he is for 420, he still has the fixed fee. This number stays constant, whatever that is. If it's 100, then it's 100 in both cases. We don't know yet. Plus, he works 7 hours times that same rate. Okay? Now, when we get two sentences, we have two number sentences now. We need to figure out how to solve them simultaneously. And often we're trying to look for things to match up. We have the R's, the F's, and the numbers. And what we're going to do is sometimes we're going to subtract the two of these and figure out some number. And in the subtraction, we want one of them to cancel out. If this one is more pushing it, we'd like this maybe to be 0. But we have two symbols. We have FF and we have R. And we're trying to accomplish getting one of them to go away. If we can get one to go away, we'll end up with something like 2x equals something or whatever, where there's only one symbol and we can solve for it now then, all right? So what we're going to do is, because we want our subtraction to be nice, we're going to flip these two sentences. So I'm going to rewrite those 420 equals FF plus, and I'm just going to say 7R now, because we know it's 7 hours times the rate, and the other one was 270 equals FF plus 4 times the rate. What we're going to do is literally subtract these two sentences. Okay? So what we're going to get is 3 times the rate. 7 minus 4 is 3. FF minus FF is 0. So this bugger cancels out. Okay? And then over here, we're just going to subtract those. So 0 minus 0 is 0. We're going to do a borrow. We're going to get 5. So we're going to get 150 equals 3x, or 3r. Right? The equal sign just drops down, 3r, and then we're going to divide by 3 on both sides. So we can get 50 equals the rate. Okay, let me just make sure we're live for a second, because YouTube has been so annoying lately. All right, so that's good. So if we look at the answer set, 50 is one of the answers. But the problem's not over. You only did half of it. Because if we read the whole problem, the end says, what is the fixed fee? We only figured out the rate. So we have to figure out the fixed fee now. So fixed fee, we can use either one of the both of these and plug in R. Okay? So let's take 270 equals the fixed fee plus 4 times 50. So this is 200. So then the fixed fee equals 70. Okay? And what we could do now is take it and plug it into the other one, which was 420 equals the fixed fee plus 7 times the 50. And we know now this is 70. So that should be 420. So we get 350 here plus 70 is 420. Okay? So we double checked it a couple of ways. You always want to go through and pop it through the both of them just to make sure. Okay? So the answer for 8 would be G. All right? Okay, for 9, I'm gonna pull up the actual sheet because my handwriting is atrocious for one thing. So we're going to look at the illustration first and then look at the questions. So we have what appears to be a rectangle in a coordinate system. We have the x coordinates, the y coordinates, and we have pretty fairly laid out coordinates, like S is 4, 1, Q is 1, 1, Q is 1, 3. Okay, so and they may ask us for the area of this thing, right? We can do something like that just by counting. You know, we can do it formally by subtracting and getting the length of each side and all this kind of stuff, or you just count. When you do something like counting, make sure if there's a key on the side, saying like what one unit equals 10 square inches or something, make sure you do that multiplication. there's no other information they're giving us here. And these are 1 through 4. We don't have one of these lightning kind of things on the side here where information is thrown away. They don't tell us what this is about. It appears just to be a mapping of a rectangle on here. It may come from some other reason. We don't know the title. So we're assuming they're asking us just something strictly, simply mathematical on this. Okay? So there's really not much information there. And so let's jump into the question. Let me just make sure that's displaying on your screen properly. It's not, so let me move this over just a smidgen. Okay, so it says rectangle PQRS above is rotated 180 degrees about the origin. This is the origin right here. 0, 0 is the origin, right? If you don't know that, you got some huge problems. I mean, this is something you need to know at least for the state test. And everything I've said so far you need to know for the state test. It's rotated 180 degrees about the origin to form rectangle PQ, P prime, Q prime, R prime, S prime. And what are the coordinates of R prime? So there's some issues here, which is that it's rotated. It's rotated a specific number of degrees. And it's about the 0 axis. So you need to be able to visualize that. So if we were to extend this out like this, and this going down, and this is quadrant 1, 2, 3, 4, and I don't care what they're called, how you normally do it. That's why I'm not using something like this. Okay, we're talking about rotating it 180 degrees. We could rotate it this way, or we can rotate it this way, because we know that a circle is 360 degrees. So however we rotate it, whether it's clockwise or counterclockwise, it's going to look the same way. So the first problem is, where does the rectangle end up? Does it end up here in this 1? Does it end up in the 2? Does it end up in the 3 area? Or does it end up in this 4 area? All right. So if you shift it 90, it's either here or here. We're not saying whether it's clockwise or counterclockwise. If it's counterclockwise 90, it's here. If it's clockwise 90, it's here. If it's 180, it's over here. So we're talking about it's going to be in this area here. Okay? And there's a couple of ways to visualize how this happens. We could do a reflection from here to here, and then a second reflection from 2 to 3. Let me say that again. We can do a reflection from 1 to 2, right? Because what we can do is take it on the y-axis and just flip it over here. And then we do a second reflection on the x-axis and flip it from here to here. Okay? We could also have done it this way. You could have done a reflection from here to here or from here to here. Okay? We can also, because it's 180 degrees, we can take a line at a 45-degree diagonal line and reflect it that way as well. Because rotations have equivalences. So I'm just giving you alternate ways to look at this. Because you have to topologically manipulate this. Some of you can do this in your heads, and some of you have to figure this out physically. So on that note, figuring it out physically, you're allowed to rotate your test paper on the test. So take your test paper and rotate it 180 degrees. Okay? And when you do so, right, the original thing was here, I rotated 180 degrees, which means it's upside down. Okay? So look, it's over here. And we can actually use this. So now these are negative coordinates. Both of them are negative coordinates. All right? So they're asking where R would end up. R is here. So this would become P prime, S prime, R prime, Q prime. So R is now right here. And if we could see this is now negative, it's minus 4, minus 4. Or sorry, minus 3, because we're over here. So that would be D. So this is a simple way to do it. First of all, if you can't do it in your head, just turn your paper upside down. Don't distract the rest of the class. And you may or may not want to give the rest of the class a clue of what you're doing, because this is kind of a test-taking skill as well as a kind of a topological perspective view. You know, if I tell you to visualize this square in your head, forget about this problem. I just tell you visualize it, and I'll tell you tilt it 10 degrees. Are you able to accomplish that in your brain without having to write it? Can you visualize it tilted slightly? Not exactly 10 degrees, but about 10 degrees. So that's the kind of thing you need to be able to do on some of these problems. And if you can't, you can take the paper and tilt it about 10 degrees just to try to get an orientation. So that's all I did here. All right? So this is kind of a quick way to do it, or at least double check what you visualize in your head. Just take the paper and turn it. If they said it was 90 degrees, then it would be something like that. All right? Because it originally started from here. So if we started from there and we turn it 90 degrees, and then we turn it 180 degrees, we're here. Okay? There's also the formalities of transformations. That's what this is dealing with, a whole branch of math called transformations. There's a whole bunch of formulas to remember it. A rotation on the axis in this way of 180 degrees means that if you have xy, there's normally an arrow produced. If it's 180 degrees, it produces minus x comma minus y. So you can memorize all these, and they're a pain in the neck to memorize. Okay, and you probably have to memorize these for some of your classes, especially if you're in grade 9 already. The teacher may or may not have covered this already. So because there's a whole bunch of transformations, rotations, reflections, shifting, dilations. There's a whole group of categories of stuff here involved in this whole transformation situation. And that's all they're asking for in this question, is if R ended up over here, what would that point look like? Okay? This is normally one of the tougher areas that kids have, because you do have to kind of memorize those things, and you do have to do the visualization as well. Because again, if you think the new rectangle is over here, then your answer has to be wrong. There's no way to get it right. Okay? So you want ways to double check it. You kind of want to memorize these things, and again, they're a pain in the neck to memorize. But you also want to do the visualizations as well. And this can be hard. It's kind of like following a map and so on sometimes. And this one is actually a pretty simple example, simple question. So some of the other questions could be a lot harder. It was pretty straightforward, but again, it's confusing. It's definitely confusing. All right, because it's easy to think that R ends up in this corner instead of in that corner, right? It's one thing you could have visualized it rotated 180, but then you're going to take this and just transplant it the same way, the same orientation it originally was. But that can't be the case, because as you spin it around the axis, and the axis here is the 0, 0, right? It talked about it floating through the origin. And there's other ways to do this, because they could have told you it was rotated 180 degrees around point P. Okay, it would still end up over here, but then you'd have to do some gymnastics and offset it from the 0, 0 for wherever P was. Okay, that's normally the twist they'll give to this. So this one was kind of lucky that it said that it was rotated on the origin. It could have said it was rotated on any of these points, or it could have even said it was rotated somewhere else. All right, so it can get more complicated that way. All right, so let's try the next one. All right, so the next one is kind of a number sense problem combined with just knowing various things. There will always be a scientific notation question, and realize this is a grade 9 problem, and you might say, oh, look at this, this is easy. And these are the ones that you want to give the attention to, because as I always keep saying, the hard problems are hard, and the problem with the easy problems is they're easy. And the truth of the matter is a lot of kids get the easy problems wrong. So how easy could they be then, right? So if you have 15.3 times 10 to the minus 8 over 1.5 times 10 to the 4th. Now there's a couple ways to approach this. I'm not dirt gut on this. This is an 8. But to me, the simplest way to approach this is to just divide this into 2 problems. We can consider this as a whole number, but it's scientific notation. So we can break these apart. We have 15.3 is one side of it, and the other side is 10 to the minus 8th. And this is 1.5, and this 10 to the 4th. So I like to look at this as A times B over C times D. And in normal mathematical situations, we can do this, A over C times B over D. In fact, there's even more variations. We could also do A over D times B over C. But for our purposes, we're not interested in looking at this. We're just kind of consider, oh, we can take things that are multiplied together and kind of split them in 2 parts. So that's where we're getting here. So consider this A, this B, this C, and this D. So what we're going to do is do the 2 problems separately. So the B over D problem is 10 to the minus 8th over 10 to the 4th. So this comes down to nothing else but exponent multiplication and exponent division. So when I have A to the M times A to the N, I get A to the M plus N. And when I have A to the M over A to the N, I get A to the M minus N. So that's our scenario in this case. So we have 10 to the minus 8th minus 4. So we get 10 to the minus 12th. Okay, so that's what this side is equal to, 10 to the minus 12th. And now on this side, we have 15.3 divided by 1.5. Okay, so this should be able to leap out at you. Both of these should be able to leap at you, but this one should be able to leap at you as well. This looks like if I was to ask the average person on the street, and even most of the kids taking the SHSAT, is this going to have an ugly answer or a really smooth, nice answer? Most kids are going to say it has an ugly answer. And the truth is it doesn't. Okay? So let's talk about, you know, everybody can do this. 1.5 goes into 15.3. Okay? What you have to know is you have to move the decimal over 1 place in both cases. That way we're just dividing 15 by 1.5 and all that kind of stuff. So we end up with 15 goes into 153. So we toss the decimal away. So that the outside number here is a whole number. We don't want a fraction out here. We don't want a decimal number out here. We want just a bunch of digits that is smooth. So 15 goes into 15 once. Because on the SHSAT, they're not going to give you ugly numbers. Often if you find you're running into ugly numbers, you're probably solving the question wrong, or you're choosing a way that's hard to solve it. Right? Let me say that again. On the SHSAT, the numbers are almost always fluid. They're not made to be super nasty, ugly numbers. They're made to be easily added, easily divided, easily multiplied, easily square rooted, all these kind of things like that. So if you're finding you're getting weird, huge, ugly numbers with lots of decimals or fraction denominators that are gigantic, you're probably solving the problem wrong. So you need to revisit it. Or you might be solving it right, but you're solving it in a very inefficient way where all your multiplications and divisions and additions and subtractions to get you those huge numbers means you're teetering in a very error-prone scenario. You're leading yourself to make a silly error that way. All right? So when we do something like this, it just works out. So 15 goes into 50 once. 15 goes into 3. It doesn't, so that's 0. We bring the decimal point up. And 15 goes into 30 2 times. Okay? So when we get back, when I asked you what would this be equal, would be a nasty number. It turns out to be 10.2. That's not that nasty. Okay? But the truth of the matter is, that answer, the 10.2, it should have leaped right out at you. Why should it leap out at you? Because we have at the denominator, even though it's 1.5 and this is 15.3, ignore the decimals for a second. We have the 15 going into the 15. We can see that. But when you look at this and you see 15 going into the 3, that's like, that's nasty, right? Because that ends up being like 1/5, which is 0.2, by the way. But if you add another 0 here, in other words, 15.3 has the same value of 15.30. We can see that 15 goes into 30 twice. So this is something that should have been done actually with no hesitation. Almost like if I said, what's 12 times 10? Everybody knows to throw the 0 at the end and then get the 120. This is the same kind of a thing. That should leap out at you, that's the division that's possible. That 15 can go into 3, because it's really not 3, it's 30. All right, so that's the kind of things you guys need to start getting, so you have a number sense. I talked about a lot of things about no hesitation math and number sense and things like that. And that's really where I'm leading up to on something like this. So what we end up with is we have 10.2 times 10 to the minus 12. And if we look at the answers, where's the test paper? Where did I put that? I have a whole bunch of tabs on the screen. Yeah, we have 10.2 times 10 to the minus 12. And if we notice, that's not one of the choices they give us. All the answers are in 1.02 form. And by the way, that's standard scientific notation form. So if this was a grid-in for some reason, this is not the answer. This is not scientific notation, or at least standardly accepted scientific notation. So in other words, normally we want to get a number in x dot y times 10 to the something, okay? And y can be more than one digit. So let's say it can be yz, for instance. This case, x is more than one digit. It's 1 and a 0. So we need to force fit, if you will, 10.2 times 10 to the minus 12. So how do we do that? Well, first of all, they're giving you a clue that it has to be 1.02. Let me rewrite this under 10.2 times 10 to the minus 12. So if we want to get it to be 1.02, what we're going to do is divide this number by 10. We're going to divide that by 10. So to make this number still be whatever it is, whatever this is x. For this to be still x, if we divide this by 10, we have to multiply this by 10. Right? Because if we take any number and divide it by 10 and multiply by 10, we should get back the same number. So if this has to be in the form of 1.02, we have to do 10 to the minus 12 times 10. And 10 is the same as 10 to the 1. So if we go back up here to this, a to the m times a to the n is a to the m plus n. Then what we have is 10 to the minus 12 plus 1, which gives us times 10 to the minus 11, okay? Which should be f. All right? All right, so that's all I'm going to do today, guys. Just took some bite-sizable examples off of here. Again, I'm Greg from GregsTutoringNYC at gmail.com. Please like the video. Please subscribe to the channel. There's still about 3 weeks to the first SHSAT, and it's probably about 4.5 to the last SHSAT. So there's still a good chunk of time to do preparation, studying, to resolve the issues you have. But at this point, if you've been doing the problems, you should be starting to figure out how to get yourself down to pacing yourself, thinking about your strategy, how you're going to approach the test on test day, what sections you're going to do first, how you're going to do your double checking, things like that. You should start considering narrowing down which specialized high school you want to go to, because you have to bubble that in on test day. That does not get entered into my schools at NYC. When you take the test on test day, the proctor will lead you through a bunch of stuff, and that's going to be one of the first few things you're going to do. You're going to bubble in which specialized high school you want. So you want to rank them and get your priority order right. The order you put them in really matters, because you can end up not getting into a specialized high school because you rank them wrong. So decide which ones you really want to go to, either because you're passionate about it. You might rule some out even if you're passionate because the distance is too far away. A whole bunch of scenarios. Even the cost of something. Some you have to take specialized buses or trains and things like that. If you live in the outreaches of Staten Island, going to Lehman in the Bronx or Bronx Science is going to be some really wild trek. So start figuring out what specialized high school you want to go to. I do a bunch of Q&A live streams. You can ask me any question about the test, not just about the ELA and the math, but about how it functions, how to rank your stuff, how to prioritize stuff. Check out my scoring live streams, right? There's a ton. So please like, please subscribe, and have a good day. Peace out.